Hello everyone. This video is for preparing for quiz 1 and we will have quiz 1 on coming Thursday, October 20th, and then the quiz will be released via Canvas. Basically, you can see the quiz 1 on Canvas starting from the 8:30 a.m. on Thursday, and the due date for finishing quiz 1 is on Friday, 11:59. So the quiz will be open for 2 days, and then you will have up to three attempts to take the quiz. I will take the highest score, so please use all the attempts if you cannot make the 100% mark for the quiz. And then each attempt, you will have technically unlimited time, but you can finish it around 30 minutes or at least in an hour uh, if you follow this quiz preparation material thoroughly. And then the quiz is with the open material policy, so that means you may refer to any contents at our course website. That means slide and then the lecture videos and even this slide, and then also for the video for this uh, today's lecture. And then you can refer to your code that you wrote for the solving challenges for the assignments. And also you are allowed to use Python because some of the quiz questions will ask you to calculate some of the value. So in such a case, you can do that with the paper and pencil, but I believe like using Python will have a less burden for you. But please make sure that we do not allow you to communicating with the others during taking quiz. So do not talk to each other and then just study and solve the quiz. And then if there is any factual error in the quiz, then please ask me the question. But please do not ask like if this answer is correct or something like that. So if there's a factual error, so you cannot understand what the question sentence is meaning, then like you can ask the questions to me. But the TA and myself will not accept any questions about checking if this answer is correct or not. And then we will have less than 20 questions in quiz 1. And then all 3 weeks contents will be covered in the quiz 1. So you can see that the topics are including the traditional and XOR cipher, block cipher mode, and then how we can attack them, and hash-based message authentication code, and RSA and symmetric encryption, and PKI, digital certificate, and DPM and key exchanges are all included in quiz 1. And from now, I will introduce like what kind of questions will be on the quiz. So like the sample questions are very similar to the questions that you will see the quiz on the Canvas. And let's start. Let's take a look at sample questions. So like I will either describe how you can solve this kind of the sample questions uh, like this one. So I will do that. Or like I will provide a question and then like if some of the slides that you can refer to as to the study about the related material for the question. So basically, you can find the answer to the question in these kind of the supplementary slides that I attached right after the sample question. So let's start. So the sample question 1 is about the Caesar cipher. So decipher the following string encrypted with the Caesar cipher, which shifts the letters, each letter by 3. So the question will include sentences like until this point. So there will be no answer provided like this. So your task is to decrypt this encrypted ciphertext. So you can either do this by paper and pencil, or you can use Python. So you can refer to the code that you wrote for the Caesar cipher. Just change some of the sentences with this one, then you can easily get the answer. And the second sample question is about which of the following description is true for the perfect secrecy. So it's about perfect secrecy. So it will give some of the choices about like what is the right description about the perfect secrecy. So You can study about the Shannon's intuition and then how Shannon's definition of the perfect secrecy is done with these kind of the following slides. Next is about the XOR cipher. Which of the following is correct for the XOR cipher? So you will see some of the choices about describing the XOR cipher, and like, you need to choose, you should choose like the correct one. And then to study about the XOR cipher, you can refer to the slide attached right after the sample question. Sample question number 4. Stream ciphers are convenient. Why don't we use RC4 or RC5 stream ciphers? Now, I believe you might forget about like a stream ciphers. We didn't cover that much, but the important thing is like there is a reason that we don't use RC4 and RC5 stream ciphers. So in that regard, please study about the following slide, this one, about like why we don't use RC4 and RC5. Next is a question about the AES and the block cipher. Sample question 5. With a block cipher, we can encrypt, decrypt a block of the message. For example, in AES, a block size is 16 byte. So we must encrypt a 16 byte by 16 byte. So in that case, how can we encrypt a message that is shorter than block size? For example, if the message is not 16 byte, if that is a 5 byte, then how can we encrypt that? In this regard, we studied about the padding scheme in the block cipher. Yeah. And then that is being used by the ECB. And CBC also uses this kind of the padding scheme. And then please study about how the padding scheme works with the attached slides. And sample question number 6. What is the reason that we can indirectly see some contents of original image if we encrypt a bitmap file in ECB mode? So this question is about the weakness, pointing the weaknesses of the ECB, and then the weakness was that like because the message will be encrypted to the same ciphertext for the same plain text. So some of the patterns of the plain text will be leaked on the ciphertext. So the image will not be directly the same, but we can see the shape of the internal contents. And then for that to answer this question, please study about the attached slides about the ECB. And then the next question is about the same bitmap file, but in this case about the CBC mode. Why is the CBC mode did not have the same problem with the ECB in encrypting a bitmap file? And then to that end, CBC is designed to kill the weaknesses of the ECB. Then please study about the how and why CBC does not suffer the same problem with the ECB like this. And then the important part is like the having a random IB and then making the random looking like a cipher text to the next plain text block and so on. And then sample question 8. In CBC mode, which block we need to apply the XOR tricks to change the plain text marked as P2? So to change this plain text block, so we know that we can attack the CBC ciphertext by altering the ciphertext itself. We can change some part of the plain text, and then this question is asking exactly about like which block do we need to edit to change the plain text of the P2. Then from the diagram, you can easily see that the ciphertext block C1 will be XORed with the plaintext P2. So you can, in this case, you can choose a C1 as the answer. Yeah. And then if you cannot follow like why this editing C1 will make the attackers control the plaintext block at P2, then please study about how the CBC attack works with the IB or some other blocks. You can also refer to your code that you wrote for solving the CBC attack challenge. Next is a simple question 9. Which of the following is false for the counter mode? So there will be some of the choices describing about this counter mode, but all the others will be the correct description, but the one choice will be the false. So you need to distinguish like the incorrect description of the counter mode among them. And in this regard, please study about the characteristics of the counter mode with these slides. And then sample question 10. Which of the following is true for the cryptographic hash function? So similar type of the question. So there will be the descriptions about the cryptographic hash function, but the only one choice will be true. So you need to choose that. And to that end, please study about the slide for the cryptographic hash. Then important parts are this kind of the implications and also the characteristics of the cryptographic hash. Sample question 11. Which of the following is a secure construction of the HMAC that protects the integrity of the ciphertext? So we learned about the HMAC, then that like if we don't protect the integrity of the ciphertext, then we can the block cipher CBC and even for the CTR mode, they suffer from the attack. And then we learned about like how we can securely construct attach the message authentication code with the hash function, cryptographic hash function, and then as a result, we can protect the integrity of the ciphertext. Then what is the secure construction of the attaching MAC message authentication to the ciphertext? So we didn't learn about the many other constructions, but please take a look at like the how the MAC then encrypt and MAC, and then the encrypt then MAC works. Then please note that the encrypt then MAC. So generating the message authentication code with the encrypted data, yeah, that is the only secure composition of the using MAC with the encrypted data. So if you choose MAC then encrypt or encrypt and MAC, then those will be the incorrect answers. Sample question 12. Which of the following is false for the RSA public key cryptography? So this is the similar type of question about the asking definitions or implications, characteristics about the RSA cryptography. So please study about this slide about that describes the RSA encryption, decryption, and there are a few slides about the digital signatures too. So please study thoroughly about these to choose the correct answer for that question. And then the sample question 13. We have 10. This question is about the key exchange problem. So we have learned about the key exchange. So if there's an n number of people, then how many keys do we need to let them communicate securely? So that kind of type of question. And then the question says like if we have 10 people, then we would like to have the secure and private communications among all these people. Yeah. So to construct this kind of environment, how many keys do we need if we use symmetric crypto and asymmetric crypto? So there will be choices like the 100 for symmetric and 10 for asymmetric or some other numbers, and then you need to choose like a correct number for the right answer. And then for this example, if we have 10 people for asymmetric crypto, we need to generate the 10 key pairs. So the correct answer is 10 and not 20. So please do not regard a public and private key as two keys. So in this case, like in asymmetric crypto, RSA, like that, we just need 10 keys. But in this symmetric crypto, you need to use this formula to calculate that. So it's something like all the number of lines that we can draw for the n number of the dots. Yeah. So like the how many edges for the n number of the fully connected graph with the node number n. Yeah, that will be the correct answer for that. So please use this formula to calculate the correct answer for the symmetric crypto case. And then for this type of the questions, please use Python or some other calculator for compute the correct number for that. Then there are descriptions about the question number 13. And then question number 14, at least generated in an RSA 4096-bit, which is a secure one, a public and private key pair. And at least published the public key on her Twitter so that anyone can access her public key. That's good. And then after that, she created a message I owe Youngjin $1 million. And then generate a hash message, hash of this message as an hash H. And then she encrypts H using her RSA private key. So generate the message S. And then she gives S to Youngjin. And then Youngjin indeed lend her $1 million. How can he do that? And then there will be some of the descriptions. And then this exactly asking about the concept of the digital signature. And then you need to choose the correct description about like the why Youngjin can ensure that she will pay back $1 million, or like the how can like the some of the law enforcement, if like the Alice does not pay back the $1 million, then Youngjin might sue her. In that case, like the what kind of things could work as an evidence. So you need to choose like the correct description about that. And then this is about the RSA digital signature scheme. So please study about the digital signature, how we can use that with the RSA with the following slides. In the sample question number 15, which of the following describes how the public key infrastructure works? So this is the similar type of the questions about like the asking about the definition, characteristics, and then about the public key infrastructures. And please study about like the how the public key infrastructure works, and then how we can verify the digital certificate, and then those kind of things. So there are several slides, but you can easily follow them. And then the last one, sample question number 16. There will be a question about the compute the secret value, compute the secret shared value via the Diffie-Hellman key exchange. So the example is something like this. But I will give you some of the little bit more bigger number for this one. Then please use Python to calculate the correct number for that. And thank you for your attention. So the quiz questions will not be much different, but almost the same with these kind of questions. So please study about this slide for before taking the quiz. And if you don't have the time, then like at least when you taking the quiz, please open this slide, and then after reading about the real quiz questions, and then please try to take a look at this slide about to study about how you can get the answer for the quiz questions. All right, thank you, and please be prepared for the quiz on Thursday.